Okay, this will be Geometry Chapter 4. The first section that I'm going to go over is the matching. It deals with classifying triangles and the definitions. This test is going to come out of Chapter 4. It's going to come from Chapter 4.1, 4.2, 4.3, 4.4, and 4.7. Not going to be responsible for 4.5 and 4.6. Matching classifying triangles and definitions out of 4.1. A good example would be in our book on page 452, dealing with these. A triangle with all equal sides is equilateral. Triangle with two equal sides is isosceles. Triangle with no equal sides, scalene. Then acute means that all three angles are less than 90. Equiangular, all three angles are the same measure, which would be 60. Right means it has one right angle, and then obtuse, one angle greater than 90. So make sure tomorrow that you understand the difference in classifying a triangle by its angle, classifying a triangle by its sides. Alright, congruent triangles. Congruent triangles in section 4.2. What we're looking at here would be something like this up here, where it gives you two triangles. And for two triangles to be congruent, then their corresponding angles are congruent and the corresponding sides are the same length. So in this triangle, angle B is equal to angle Y, angle A is equal to angle X, angle C is equal to angle Z. So if I were going to write that so that it was a congruent statement, I would say triangle BAC, triangle BAC is congruent to triangle YXZ. The order of this is very important because it lets me know that angle B and angle Y are congruent, angle A, angle X, angle C, and angle Z. Then the line segments that are congruent are the sides BA, YX, AC, XZ, and then BC and YZ are congruent. So that comes from 4.2. Okay, 4.3 and 4.4 are basically what we're looking at here are section 3 deals with triangle congruence. Now there are there are three postulates and one theorem. Side, 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 angle, side, angle, side, and angle, angle, side. So the way this goes is when they give me, for instance, in our book, let's look, and this is on page 253. If I look at, say, for instance, number 9 right here, this would be angle, side, angle. Angle, side, angle. So they are congruent based on angle, side, angle. Number 10, looking at it, they give us two sides and one angle. There's no congruent statement for side, side, angle. So that would be there's not enough information. And then lastly on 11, it's going to be angle, angle, side, because I know this angle, these two angles are congruent because they correspond since those two lines are parallel. So it's angle, angle, side, which is the theorem. Okay? Lastly, 4.7, which I think probably is one of the easiest parts, is placing a figure in a coordinate plane. So if I tell you, for instance, to place, it may say place a right triangle with a base of 6 and a height of 4, and then label the vertices, and so label the vertices, and then label the coordinates. Okay? So if I were doing this, I would draw my coordinate plane. Doesn't have to be fancy. I would put my first point at 0, 0. Call this point A, and it's going to be at 0, 0. I always pick 0, 0. It's the best place to put it. Alright, the base would be 6, and I'm going to go 1, 2, 3, 4, 5, 6. We'll call that point B, and that coordinate would be 6, 0. Then I'm going to go up 4 here because the height is 4, so 1, 2, 3, and 4. Call that point C. That is at 0, 4. So there's my 3 points. Connect this, and here is my triangle, and it's a right triangle, so we have to have a right angle right there. Okay, on this, if I wanted to know what the length of the hypotenuse was, I know this side is 6 and this side is 4. So I'm going to do the Pythagorean Theorem. A squared plus B squared equals C squared. Or I'm going to say 4 squared plus 6 squared equals C squared. So that'll be 16 plus 36 equals C squared. 52 equals C squared. Take the square root of both sides, and that's going to be about 7. Calculator out. Tell you right. Square root of 52, 7.2. Now, this is going to be a bonus. Probably not this exact way to do it, but you're going to need to do a Pythagorean theorem. Find out that that is 7.2. So make sure you know your vocabulary. Make sure you know side, 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 angle, side, angle, side, angle, side, and angle, angle, side. And then any other problems that we went over in the book, you know, knowing that triangles add up to be, the interior angles equal 180, and the things we went over on our review. Make sure you know that. Real quick, if you messed up and you didn't get the review that we went over, it would look something like this. To give you a quick scan, we did this in class. I'm not going to spend a lot of time on it. I gave you an example of congruent triangles. I gave you an example of problems where you had to find or solve for x based on angles being congruent, knowing to set them equal like that. This would be a problem where I give you, look for x, give you 80. 180 minus 80 is 100, so I have to split 100 evenly 2 ways. I get 50 and 50. This is one where the exterior angle is equal to the sum of the two remote interior angles of the ones farthest away. 70 plus 60 is 130. Again, this deals with 4, 3, and 4, 4 are congruent. That's an example of angle, angle, side. The second one's not enough information. The third one is side, angle, side. And then section 4.7 is another placement, placing the figure in a coordinate plane. And isosceles right triangle, where vertex is at 0, 0, the legs are 4 units. In which there I should put it at 0, 0, my legs are 4 units. I went ahead and found the length of the hypotenuse to be 5.65 for that. So that's your test. Good luck, and that does it for chapter 4.